The question says we should form a PDE from z is equal to f of x plus ay plus phi of x minus ay, where f and phi are functions. It means we want to eliminate the what arbitrary function f and what phi in this given relation. How are we going to form a PDE? By eliminating the arbitrary function in this given relation. First is what we differentiate with respect to x partially, then we differentiate that given function with respect to y partially. We now consider in second order how we are going to form a what a new PDE from the given relation. So solution to this, number one, z is f of s plus ay plus phi. Phi is the letter s minus ay. So it means we are going to differentiating partially with respect to x in equation 1. Let me call this one equation 1. So let us differentiate partially with respect to x. I have z here. If I differentiate z, I'm going to have partial z partial x, or the z the x. Either way you call it. Remember how we differentiate this. We are going to differentiate f prime. F prime then multiplied by all what is inside the bracket, s plus ay. Multiplied by what? I'm now going to differentiate what is inside the bracket with respect to the given value that we are asked to differentiate. If I differentiate x, I'm going to have 1 plus. If I differentiate a here and y is not a function of what? X. So it's going to be a constant. If I differentiate a constant, I'm going to have 0. That is 1 plus 0. So I'm going to have 1. Then next is what? Plus to differentiate this one also with respect to x, I'm going to take this sign, Greek letter, phi. Differentiate this phi, I'm going to have 5 prime. Then s minus ay. I'm going to differentiate, I'm going to write what is inside brackets here to multiply it. Multiply by what? With respect to what? I'm going to differentiate what is inside the bracket with respect to x. If I differentiate x here, I'm going to have 1. Minus, if I differentiate ay with respect to x, they are all at 0, I'm going to have 1. So it means my notation for the z over the s is p is equal to f point s plus ay times 1. I'm going to have this plus empty, we call it phi, then s minus ay times 1. So I can name this one is equation 2. So what's my next step? To differentiate equation 1 again with respect to what? Y. Differentiating partially with respect to y in equation 1. So by differentiate z, I'm going to have die z over what? Die y. Take this f, differentiate a function of f, I'm going to have f point, then s plus ay. Multiply by what? I'm differentiating with respect to y. If I differentiate with respect to y, I'm going to have x is 0, 1 plus. Differentiate a with ay is a product. I'm going to differentiate y here. If I differentiate y, I'm going to have 1. 1 times a, I'm going to have a. Plus, take the second one, 5 prime s minus ay. To differentiate what is inside the bracket with respect to y, plus, let us differentiate this. 1, if I differentiate s, I'm going to have what? 1. 1. If I differentiate x here, I'm going to have 0 minus. If I differentiate ay here, if I differentiate y, I'm going to have 1. 1 times a, I'm going to have minus a. So 0 minus a is what? Minus a. So I'm going to have minus a, multiply by minus a, multiply by minus a. The notation for the z, the y is q. I'm going to have q is equal to f prime x plus ay multiplied by what? 1 plus a, I'm going to have a, times a, I'm going to have a. So I'm going to have q is equal to a, f prime, plus this one is dot. Dot is a multiplication. So I'm going to have minus a, plus times minus, I'm going to have minus a phi x minus ay. You can see from equation 1 and equation 2 and equation 3, you can see that there's nothing related to each other. You cannot add equation 2 to equation 3. Why you cannot add what? You cannot divide equation 2 to equation 3 because there's nothing common there between them. You can see that they are different. A is here, A is not here. But how are we going to eliminate the arbitrary function in this given relation? In this given equation 2 and 3, it means what? We are going to consider higher degree, whereby we are going to differentiate x, the z over the x again with respect to x. Then we are going to differentiate y again with respect to what? Y. So we are going to consider higher second order. So if you consider higher second order, it means we are going to differentiating equation 1, equation 2 partially with respect to x. What's our equation 2? Our equation 2 is p. It means our notation for p is the z over the x, which means if I differentiate the z over the x, I'm going to have the square z all over what? The x square, which is what? Which is equal to what? Which is equal to what? R. So the notation for this is r. So it means I'm going to have r is equal to. So let us differentiate this with respect to what? With respect to what? X. I have f prime already. If I differentiate again, I'm going to have f prime prime, then x plus y. What's my x plus y? Let me use that pen. So I'm going to have r is equal to, I have f prime. If I differentiate again, I'm going to have f prime prime, then x plus ay, x plus ay. If I differentiate x here again, I'm going to have 1 plus, let us 5. I have 5 prime. If I differentiate 5 prime again, I'm going to have 5 prime prime, then x minus ay. If I differentiate x here again, I'm going to have 1. So that means my r will now be r is equal to f prime prime x plus ay plus 5 prime prime x minus ay. Equation, let me call this one equation 4. So next step is what? To differentiate partially. To differentiating equation 3 partially with respect to y. So it means if I differentiate with respect to y, I'm going to have the notation. I have the z all over the y. If I differentiate again, I'm going to have the square z all over what? The y square. So it means if I differentiate the z over, I'm going to have the square z all over what? The y square. And the notation for this is p. The notation for this is t. So whereby I'm going to have t is equal to, let us consider this equation 3. So I have a f prime x plus ay. So I'm going to have, I want to differentiate this with respect to y. So it means I have a f prime prime. I will differentiate f again, f prime prime x plus ay. So I will not differentiate what is inside this and multiply together. Multiply by what? If I differentiate x here, I'm going to have 0. Differentiate y here, I'm going to have 1 times a. I'm going to have a outside. Plus the second one. What do I have there? Minus. I have plus then minus. If I differentiate minus a phi prime prime x minus ay. Remember that I have 5 prime. If I differentiate 5 prime prime, if I differentiate 5, I'm going to have 5 prime prime, then x minus ay. So I'm going to differentiate what? I'm going to differentiate x with respect to y. I'm going to have 0 minus, I'm going to differentiate y here, 1 times a minus a. Because it's what? Because it's what? Minus a. Because it's a product. So minus a times this. Let me open this bracket. I'm going to have t. I'm going to have t is equal to a f prime prime x plus ay multiplied by what? A times c, I'm going to have a square plus, what do I have here? A plus times minus is minus. I'm going to have minus here. So minus times minus here, I'm going to have what? A square. So plus times minus is minus times minus, I'm going to have a square again. A square 5 prime prime x minus ay. I can call this one as equation 5. So you can see from here that I got in my equation 4, I got this. In my equation 4, I got this. So I can consider that what can I see in equation 4 and equation 5 by comparing f prime prime s plus ay plus 5 prime prime s minus ay are present in both 4 and 5. I can make a square. I can take the common terms in equation 5, which is what? A square. So I'm going to have t is equal to a square, open bracket, f prime prime s plus ay plus 5 prime prime s minus ay. So t is equal to a square. You can see that I take the common terms, which is a square, to open the. If I use a square to multiply this one, I'm going to have this one back. So what's my next step? My next step is to what? Check equation 4. You can see that I make a square. When I take a square as a common term, and that is what? F prime prime s plus ay plus 5 prime prime s minus ay, which means that what gives us this is r. So it means we have what? R here that gives us this. So if you multiply this one by, I'm going to have t is equal to a square r, which is the required PD, which is the required partial differential equation. It means I have formed a PDE to how, which is the required PDE. That is, I have eliminated my what? I have eliminated f and phi as my function, which I got my newly partial differential equation. I hope you find it interesting, and don't forget to subscribe and share to others. Thanks for watching.